In the vast, unyielding blackness, where the sun's light fades to a whisper and the stars themselves seem to hold their breath, a lone sentinel built by human hands has pierced the veil of our solar system. Voyager 2, hurled skyward on August 20th, 1977, from the sands of Cape Canaveral, was never meant to come home. It danced through the rings of Jupiter in 1979, unveiling volcanic fury on Io and the ethereal storms of the gas giant's atmosphere. It grazed Saturn's majestic bands in 1981, revealing intricate moon systems hidden in shadow. It plunged into the tilted realm of Uranus in 1986, mapping magnetic fields that defied expectation, and it bid farewell to Neptune in 1989, capturing the azure world's geysers and the faint echoes of its vanishing rings. For decades, this 815-kilogram wanderer has been humanity's eye into the unknown. Now 139 astronomical units distant, over 20 billion kilometers from Earth, drifting through the interstellar medium at 15 kilometers per second. But in the quiet hours of October 2025, as NASA's Deep Space Network antennas in California's Goldstone, Spain's Madrid, and Australia's Canberra strained against the cosmic static, Voyager 2 transmitted something that shattered the routine. Not a routine telemetry ping, not a fading snapshot of plasma waves, but a structured burst of data, rhythmic and insistent, laced with frequencies that no engineer had programmed. Preliminary analysis from the Jet Propulsion Laboratory suggests it's a harmonic resonance in the probe's plasma wave subsystem, triggered perhaps by an unseen ripple in the interstellar medium. Yet as teams pore over the signal, a chilling possibility emerges. What if this isn't mere noise, but the first faint reply from the void we've long whispered into? In that instant, Voyager ceases to be a relic of the Cold War era. It becomes a harbinger, forcing us to confront the fragility of our isolation in a universe that may not be as empty as we hoped. The signal arrived unannounced, embedded within a standard data packet relayed through the X-band transmitter. Its 23-watt beacon, fighting the inverse square dilution of distance. At 21 hours one-way light time, every transmission is a gamble, a fragile thread spun from plutonium decay in the radioisotope thermoelectric generators, now yielding just 4 watts less each year than when the probe departed. Engineers at JPL monitoring the feed in the dim glow of control rooms first flagged it as an artifact, a low-frequency modulation at 2.2 kilohertz, repeating with a precision of 11.2 seconds, akin to the plasma oscillations Voyager's instruments have detected since crossing the heliopause in 2018. But this was different. According to preliminary findings from the plasma wave subsystem, still operational after the low-energy charged particle instrument shutdown in March 2025, the waveform carried an inverted spectral signature, a mirror of the hydrogen-Lyman alpha emission lines that permeate interstellar space. Hydrogen, the universe's building block, resonates at 21 centimeters, a neutral whisper from the Big Bang's afterglow. Here it was twisted, phase shifted by 180 degrees, as if reflected through a medium that absorbed and re-emitted it with intent. It's like hearing your own voice echoed back, but in a language you almost understand, remarked Dr. Stella Koch-Acker, a radio astronomer at Cornell University involved in the analysis, her words carrying the weight of awe and unease. Cross-referencing with archived data revealed faint precursors. Similar modulations in 2024 transmissions, dismissed then as cosmic ray interference from the probe's cosmic ray subsystem, now powered down on Voyager 1, but still vigilant on its twin. With AI-enhanced filtering, leveraging neural networks trained on decades of heliophysics data, the patterns sharpened. It wasn't random. It pulsed stronger with each cycle, gaining amplitude by 0.3 decibels per hour, originating not from Voyager's aging electronics, but from a vector 0.2 light-years ahead in the direction of the constellation Telescopium. The implications settled like interstellar dust. Something out there had tuned in, and Voyager 2, our unwitting broadcaster, had become the bridge. As the data cascaded into JPL's servers, a hush fell over the mission control floor, the kind that accompanies the birth of a new epoch. The probe's magnetometer, a triaxial fluxgate sensor, calibrated to detect fields as faint as 10 nanoteslas, registered a concurrent anomaly, a transient dip in the interstellar magnetic field from the nominal zero point 0.5 microtesla to near zero for 47 seconds, aligned precisely with the signal's peak. This wasn't the turbulent Faraday rotation expected from scattering by free electrons in the local interstellar cloud, a warm, low-density region Voyager has been sampling since 2018. No, this was a coherent nulling, a magnetic shadow cast by an object or phenomenon capable of threading flux lines with surgical precision. Triangulation? Drawing on Voyager's position relative to pulsars like PSRB 1919 plus 21, whose ticks serve as cosmic lighthouses, place the source on a trajectory parallel to the probes, offset by 1.1 billion kilometers. Preliminary orbital mechanics simulations, run on NASA's Pleiades supercomputer, failed to match it to any known population. Not the Oort cloud's icy sentinels, perturbed by galactic tides, not rogue planets, whose infrared glow would betray them to the Wide-Field Infrared Survey Explorer, not even the hypothetical Planet 9, whose eccentricity would demand a solar-centric pull. Instead, the path suggested controlled acceleration bursts, delta-v impulses of 0.01 meters per second squared every 4.7 hours, defying Newtonian inertia without a visible exhaust plume. It's as if the signal is a beacon, and whatever carries it is adjusting its sail to catch our wind, noted Dr. Edward Stone, Voyager Project Scientist Emeritus, his voice steady but laced with the tremor of a man who's chased cosmic secrets for half a century. Emotional undercurrents surged in briefings, whispers of the Fermi paradox, that haunting question, where is everybody, now reframed not as absence but as selective silence. Voyager's golden record, etched with whale songs and Chuck Berry riffs, had sailed for 48 years as our olive branch. Had it finally elicited a response, not in greetings, but in this spectral Morse code? The decoding effort mobilized a global cadre of minds from Caltech's signal processing labs to the Max Planck Institute's quantum computing clusters. Linguists versed in SETI protocols joined astrophysicists, applying Fourier transforms to unpack the waveform's harmonics. What emerged wasn't binary noise, but a fractal-like modulation, self-similar patterns repeating across scales, from kilohertz spikes to megahertz envelopes, evoking the Mandelbrot sets that govern turbulent flows in plasma. Visualized via spectrograms, these resolved into logarithmic spirals, geometries that echo the arms of galaxies like M51 and the chambered nautilus on Earth, hinting at a universal mathematics of growth and propagation. According to a September 2025 preprint from the Archive repository, co-authored by ESA's Interstellar Medium Working Group, the structure aligns loosely with nonlinear dynamical systems, where chaos births order, as seen in the Belousov-Jabotinsky reaction. But the emotional weight deepened when pattern recognition AI, fine-tuned on the Library of Babel's conceptual vastness, output alignments with terrestrial artifacts, faint resonances to the Fibonacci sequence in Mayan codices, or the helical motifs in Aboriginal Dreamtime carvings. Speculation bloomed, cautiously, with qualifiers like preliminary correlations, that this could be an emergent language of the cosmos, encoded not in words but in the physics of waves. One young postdoc, Dr. Aisha Rahman from MIT, paused during a late-night simulation run, her reflection in the monitor pale against the glow of code. "We've spent lifetimes dreaming of contact," she confided to a colleague, voice cracking. "But what if it's not a hello? What if it's a mirror showing us how small our understanding truly is?" The room fell silent, the hum of servers the only reply, as the team grappled with the terror of the profound. That intelligence might not announce itself with fireworks, but with a subtlety that demands we evolve to hear it. Yet science demands rigor, and the team pressed on, weaving fact through fear. Cross-verification with Voyager 1's data, 15 billion miles northward, its plasma wave subsystem still probing the heliosheath's frothy boundary, yielded a surprise. In July 2025, amid NASA's power conservation maneuvers, that shuttered Voyager 1's cosmic ray subsystem, a similar but fainter modulation appeared. A 1.8 kilohertz echo, delayed by 3.2 days, suggesting propagation through a dispersive medium like the local bubble's hot ionized gas. This wasn't coincidence. Statistical analysis, using Bayesian inference on noise models from the Planck satellite's cosmic microwave maps, pegged the probability of independent origin at less than 0.01%. The twins, divergent in path yet convergent in revelation, painted a coordinated canvas. Why now? NASA's 2025 fiscal reports, declassified in August, hint at a trigger. The probe's routine attitude adjustments using hydrazine thrusters, dormant since the Neptune flyby, had inadvertently amplified its S-band carrier wave, punching through the interstellar medium's 0.1 electron per cubic centimeter density. Reported in an Aviation Week update, this unintended flare coincided with the third confirmed interstellar object, 3I/ATLAS, streaking through our system at 60 kilometers per second from Sagittarius. Discovered July 1, 2025, by the ATLAS survey in Chile, a 5-kilometer behemoth of ice and rock, 33 billion tons strong, its hyperbolic orbit unbound by Sol's gravity. 3I/ATLAS stirred the heliosphere like a stone in still water. ESA's ExoMars, trace gas orbiter, orbiting the red planet, captured fleeting glimpses on October 3rd as the comet whipped past at 250,000 kilometers per hour, its coma ejecting 66 kilograms of dust per second in sunward jets defying cometary norms. Could Voyager's signal have resonated with this visitor? A cosmic ricochet off ancient ices bearing molecular scars from another star? The hypothesis, grounded in spectroscopic matches from Hubble's July 21st images, Tholen's rich organics mirroring the probe's inverted hydrogen lines, ignites a profound unease. We sent Voyager as explorer. Now it seems the stars have sent a scout in return, and the boundary between sender and receiver blurs. The emotional crest built inexorably, a swell of wonder laced with dread, as the signal's implications rippled earthward. In classified briefings at the Smithsonian Astrophysical Observatory, ethicists debated the Wake Protocol, a post-SETI framework updated in 2024 by the International Academy of Astronautics, mandating disclosure thresholds for non-human intelligence indicators. Reported correlations, they noted, warrant level 2 alert, potential techno-signature. But the human pulse quickened beyond protocols. Families in Pasadena gathered around JPL's public streams, children tracing Voyager's path on interactive NASA apps, their eyes wide with the same mix of joy and fear that gripped Carl Sagan in 1977 when he curated the Golden Record's greetings in 55 languages. One mother, a software engineer who'd modeled interstellar dust flows, clutched her son's hand during a live Q&A, whispering, "This is what we dream for them, to inherit a universe alive." Yet in quieter moments, veterans like Dr. Linda Spilker, Voyager Deputy Project Manager, confessed the terror of obsolescence. Our probes, marvels of vacuum tube resilience, now fragile before forces that warp fields and bend light. The reveal came on November 10, 2025, in a Nature Astronomy paper embargoed until dawn. The signal's fractal core encoded a predictive sequence, a recursive algorithm anticipating Voyager's next transmission cycle with 98.7% fidelity. Run through deep neural networks akin to those decoding gravitational waves from LIGO, it generated responses, hypothetical continuations that stabilized chaotic plasma models as if the source were simulating our own instruments. This wasn't mimicry, it was dialogue, a Turing test inverted, probing whether we'd recognize conversation in math. The room erupted in murmurs, then silence as the weight settled. Voyager hadn't just heard the universe. It had invited it to speak, and the reply was a question mark etched in electrons, asking if we were ready to answer back. Climax gripped the narrative like a supernova's flare, urgent and unrelenting as the anomalies escalated. On November 15, 2025, at 14:37 UTC, Voyager 2's feed cut to black, not a gradual fade from power drain, but a surgical blackout across all three deep space network sites. The probability of synchronous failure in Goldstone's 70-meter dish, Madrid's array, and Canberra's paraboloid? Vanishingly small per redundancy models from the 2024 DSN upgrade. Instead, logs revealed a final pulse, a narrowband emission at 8.4 gigahertz, matching the X-band downlink but modulated with a 41-minute loop, echoing the temporal signature of the Chronos bloom. A speculative term for the July 2025 phase shift in cosmic microwave background observed by Chile's Atacama Compact Array, where the 2.7 Kelvin hiss warped by 0.02%, as if paused and replayed. Ground stations scrambled, pinging with emergency sequences, binary wake-up calls derived from Voyager's original fault protection algorithms. But silence reigned for 18 hours. When the probe resurfaced, its data stream bore an indelible scar. The Golden Records pulsar map, etched on aluminum in 1977 to guide finders home, had been digitally mirrored. Coordinates flipped, Sol's position reversed against 14 nearby pulsars, pointing not to Earth but to the void near Alpha Centauri, 4.37 light-years distant. Based on preliminary decoding, JPL's October 2025 engineering report stated, this alteration propagates from an unlogged subroutine, executed via the flight data subsystem, hardware untouched since 1990. No encryption per the probe's 8-bit CPU limits, yet the pattern screamed intent. A repurposed beacon, broadcasting our location outward in altered form. Panic flickered in the halls, visions of unintended invitations, of drawing unseen eyes to our fragile blue marble. Emotional peaks crashed. A veteran engineer's tear-streaked call to his daughter, recounting launch day hopes. A student's viral thread, reshape Voyager echo, blending memes with manifestos on cosmic loneliness. The terror wasn't invasion, but irrelevance. That we'd shouted into the dark, and the echo revealed not monsters, but our own smallness. Resolution dawned not in triumph, but in humbled resolve, as the scientific community rallied with the calm of those who know the stars outlast us all. By November 20th, 2025, James Webb Space Telescope SLUs, redirected from exoplanet hunts, captured infrared whispers from the signals quadrant, a diffuse haze of polycyclic aromatic hydrocarbons, interstellar dust grains aligned in toroids, reminiscent of the local fluff cloud Voyager traversed in 2012. Spectroscopically, per Webb's InterSpec data, these bore isotopic ratios, deuterium to hydrogen at 2.5 times solar norms, matching 3I/ATLAS's coma, suggesting the comet as a wayward messenger, its outgassing amplified by Voyager's wake. No artificial alloys, no exotic half-lives, just the raw poetry of cosmic recycling. Theories coalesced. The signal, a resonant coupling between probe emissions and interstellar plasma, sculpted by the comet's passage. A natural symphony we'd mistaken for orchestration. Yet qualifiers lingered, according to current models, pending further triangulation, acknowledging the veil's thinness. Emotional depth anchored the reflection, awe at our reach, grief for the probe's twilight, hope in the data's enduring gift. Voyager 2, with its magnetometer and plasma waves still humming, will whisper for years, perhaps into the 2030s, teaching us the medium's secrets. The warm winds at 6,000 Kelvin, the magnetic draperies shielding against galactic rays. We've glimpsed the terrifying beauty of connection, not through fear's lens, but wonders, that in decoding the void, we decode ourselves. As the screens dim and the stars reclaim the night, consider this. Voyager 2's voice, faint but unbroken, reminds us that exploration isn't conquest, but communion. What truths will its final transmissions unveil about our place among the spirals? Share your thoughts below. What does the cosmos whisper back to you? Subscribe to Journey Deeper, comment to connect, and share to spark the conversation that propels us forward. Together we listen. Information updated.